Okay, I gave you, or should have given you, hopefully I remember to give you a little baggie of these chips. They're called counters. Okay, and so there is a yellow side. So those are the positive ones. And then there is a red side. So those are the negative ones. Okay. And so I am using these notes. The ones that are red are going to be filled in. They're going to be shaded kind of gray. And the ones that are positive are going to just be blank. They're going to look like that. Okay. If you want to get out those counters, you definitely can. They might help you with this. And you can kind of lay them out and look. But if you look at this first set, so if I have 3 of those positive chips, this answer is 3. Okay, and if I count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I have 10 negative chips. And if I count these 1, 2, 3, 4, 5, 6, 7, I have 7 positive chips. So you're just counting them. Okay, so then this is where those chips might help you. Okay, when you add these numbers together, you have 2 positives. And you have 1, 2, 3, 4, 5, 6 negatives. And so that's what this problem is saying. It's saying 2 plus a negative 6. So you're adding them together. Okay. They call them zero pairs. When a positive integer and a counter is combined with a negative integer, they cancel each other out. So if I have 2 plus a negative 2, those are going to cancel to 0. So these cancel and these cancel. And if you look at what's left, so those 2 cancel out. And if I look at what's left, I'm left with a negative 4. So to find the sum of 2 integers, use the counters to eliminate your zero pairs. You're literally going to pull them off and say, okay, these go together, they go away. All right, so if I look at this one, if I look at this 2 plus a negative 6, this is a zero pair, that cancels. This is a zero pair, that cancels. And then what I have left is my answer. So my answer is a negative 4. Okay. So if I look at these next, and if you look at this, if you look at the numbers, you're basically subtracting them. You're taking 2 away from the 6, but they're still negative. So some kids come up with some tricks because you can't walk around with counters for the rest of your life. So if you have $2 in your pocket and you owe me 6, you still owe me $4. You're still in the whole $4. You only paid me back 2. Okay. All right. So if you look at the next one, let's cancel out our zero pairs. Here's a zero pair, here's a zero pair, and here's a zero pair. So those cancel out. And if I count what I'm left with, 1, 2, 3, 4, 5, 6, 7, I'm left with 7. So again, if I subtract those, 7, 10 minus 3 is 7. And then I keep it as a positive because there's more positive counters. Okay, if I do my zero pairs, those cancel, those cancel, those cancel, those cancel. And I'm left with 1, 2, 3, 4, 5. So I'm left with 5. And again, if you subtract 9 minus 5 and you keep the sign of the bigger one, you'll get the same answer. So on this next one, you cancel zero pairs, right? And so you're left with 1, 2, 3, 4, 5, 6, but those are reds, those are negative. So your answer is a negative 6. So again, I just took the numbers. 7 minus 1 is 6, and I kept the sign of the bigger. Okay. Now this is interesting. There are no zero pairs anywhere. I can't cancel because they don't cancel each other. So now you're just totaling 1, 2, 3, 4. So my answer is a negative 4. So if the signs are the same, you actually add them and you keep the sign. Okay, so I'm adding them and I'm keeping that sign. Yes? Okay, so again, my signs are the same. Okay, so I'm taking this thing and I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 negative counters. And you can also get that answer by saying 8 plus 5 is 13. Since they're both negative, it's going to continue to be negative. So my answer is a negative 15. 13, sorry, I can't add. All right, so if you're writing an expression to represent the sum, so this would be 6 plus a negative 4, right? That's my expression. And this one would be a negative 2 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. A negative 11, right? Yes. Okay. So if I model these with counters, this would be 1, 2, 3, 4, 5, 6. And these are, if you want to model them, you can put pluses in them or you can fill in the ones that are negative. I don't care. So you can sit here and go plus, 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 plus. 1, 2, 3. And I'm going to put pluses in these. So my answer is 9. Okay, which you know that one. So if you want, instead of putting pluses and minus, 1, 2, 3, 4, 5, 6, 7, 8, you can actually fill in the negative ones to represent reds. So I'm filling these in because they represent negatives. So if I count that up, nothing zero pairs out. So I'm adding them together and it's a negative 14. 2 negatives is going to just make it more negative when you're adding. All right, so I'm going to do this one. So if I do 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so I'm going to go 0. Pair 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that leaves me with 4, but they're filled in, so my answer is a negative 4. So again, if you go back to the rules, because we're going to do these without the counters, if you go back to the rules, if the signs are different, you're going to subtract the numbers and keep the sign of the bigger because there's going to be more negative ones left. Okay, so if I do the next one, I have 1, 2, 3, and then plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. These are 0 pairs. And so if I look, I'm subtracting those. And so and it's more positive, so my answer is 16. Okay, on the next one, I would have 1, 2, 3, 4, 5, 6, 7, plus 1, 2, 3, 4, 5, 6, 7. And if I do 0 pairs, those are a pair. Pair go to 0. Pairs go to 0. Pairs go to 0. 0, 0. So they all match up, which means my answer is 0. So the last one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Plus 1, 2, 3, 4, 5. And I have 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs. So I'm left with 6, and those are positive, which the bigger number is positive. So 11 minus 5 is 6. So my answer is 6. So without finding the actual sum, think about whether it's going to be, all you have to do on this part is literally write positive or negative. So it's what we were just talking about. And this is important concepts. Like I said, it might feel like I'm treating you like a baby. We're doing all this stuff, but it's a hard, as you get older, these start to get more confusing. So the bigger number, to justify it, the bigger number is 10. Like number, we're not looking at like right and left. The number itself, there's going to be 10 positive chips. So the answer to this is positive. And on this one, the bigger number is a negative 12. Just the number is 12 is bigger than 7. So there's going to be more red chips, which means this is negative. And here, the bigger number itself is a positive number. Okay, so what I would like you to do is to do 21, 22, 23, 24, and 25. So all you're doing is telling me positive or negative. Now, on 21, pause and do them, please. Give you a second to remember to pause. On 21, they're both negative. So all you have laying down is red chips. Your answer is negative. Okay, on 22, this is the bigger number, so there's going to be more red chips, so my answer is negative. 23, 15, so my answer is positive. These are both negative, so all of your chips are going to be red, so that's negative. And then the bigger number here is positive. So it's just a matter of understanding when you get a positive answer and when you get a negative answer.